Hello everyone, welcome back to my channel. In this video I'm going to be showing a part 2 to creating a custom modern upgrade for the Lemax Isle of Doom as far as the step down power supply goes. And in my previous video I explained a bit about what the different boards do, what their function is, and now I have created this modern step down transformer soldered onto the original board to actually power things, which I'll show in a second. So this was the old transistor, which was mounted to this heatsink here, and it basically took 30 volts DC from this board with the yellow and white wires to here. So this rail is negative, and then that one there was the 30 volts positive, and then that would step it down to the 5 volts or 4.5 volts ish on this rail. And this red wire goes to this board, which is the main sound chip and animation manager, and also this is powering the motors. So all of the little fan motor, the top lighthouse motor, this guy's animation motor, and the animated door that goes in and out. Because this board basically operates on the same power as a regular Lemax building, which is about the 4.5 volt range. So now basically I put the positive and negative to the input of this, and then the output is the negative wire output goes to the negative rail, and then the positive goes to the same output from the transistor. So it's on the same, it's basically the middle contact of this transistor. Where the middle contact was soldered is where you want to solder the positive output to. And then additionally I wired this positive, so this is 30 volts positive going to here, which wasn't previously used. And then on the back I have a 220 ohm resistor going from there, so going from the positive 30 volts across to the old center contact here. And this is to power the LED lighting. I'm honestly not sure what they really have going on with the lights, but basically right here and right here are two different LED light output powers. And this is just reducing the 30 volts DC down to a manageable level for the LEDs. So it's just current limiting them through these resistors here. What's a bit bizarre is, I guess they wanted a regulated power supply for the sound chip and motors, because those use more power than LEDs, and it's a bit hard to get a regulated steady power for stepping down if you don't use transistors. So if they had just used resistors to step down power, it would have been more unreliable. So that's why they did use the transistor there. But the LEDs just have resistors stepping down power, and they're not powered from the 5 volt output. So if you modify this like I did, you need to make sure that the LEDs are still going to get power, because otherwise they won't light up. And so now if we go ahead and plug in, you see that all of the lights are on, and the motors are working. This one's lights went out, and I still have to troubleshoot that, but that's an unrelated issue. You can see the little fan motor there is spinning. And so the benefit of doing this upgrade is this is way cooler. Basically, the original got pretty warm and hot very quickly. And since this transistor is going to be running whenever the building is turned on, It's kind of important to have a decent step-down transformer, because if that blows up, if this goes bad, it could potentially kill the main sound chip, so then you won't have any decent sounds or animation. And it'll also kill the motors if you let it run long enough while it's dying. And so I was just sort of getting a bit worried that this was starting to go bad, because it is getting a bit old now, and the more you run it, the higher chance there is that it'll eventually die. So with this upgrade, it should last a long time. And this chip here only costs like $1 or so. So if you have the soldering skills, it's a worthwhile upgrade, because this is able to run for a lot longer and not get nearly as hot, because this is a more modern transistor. If you do replace it though, you'll need to make sure you have a voltmeter to regulate this, because you need to tune the potentiometer here down to the 4.5 volt range. I put it at about 4.40 volts, just because if you run it at a bit low, it won't hurt anything. If you run it a bit hot, so a bit too high, then your motors might burn out a bit faster, and the sound chip probably won't last as long. And that's the same reason why I put this resistor behind here. It wasn't really necessary, but just I can sort of tell from the LEDs lights that they were running a bit hot, so they were a bit bright. So that's why I put the resistor there, is just to prolong the lifespan of the LEDs, because they should last a lot longer if you have them running at a bit lower power. Anyway, thank you for watching. If you have any questions or comments about this, just let me know. I'm happy to answer any questions you might have.